see the aggression and how the wind.
Appears to be structures on fire, fully involved. The people where we are now went from safely watching from across the lake to frantically evacuating themselves. We witnessed embers jump from the west side across to the east side of the lake where we are here.
And more hellish, trees candling, home after home up in flames.
When Dr. Tahiri gave us this project, we were pretty excited. Unlike most, this project allowed us to create something meaningful and something that could create a difference. This year's topic is wildfires.
To gain an understanding of the industry and the problems that come along with it, we reached out to Theo, a firefighter with 15 years of experience.
No, you're all good. It's perfect. Okay, so yeah, I'll just get you to introduce yourself.
Okay. I'm Theo Van Zyl. I have worked in wildfire for 15 years between 2008 and 2023.
Earlier in the year, kind of at the start of the semester, we were on a call and you pointed us in the direction of hotspots. Can you kind of explain what those are and why they're a risk?
A hotspot is something that is missed or is burning deeper in the ground that could, with changing weather or fire behavior, could flare up again. And then what the goals are after the initial pass, crews would go, if not with a map showing us where the hotspots are, we would have to go and just walk and grid the forest by ourselves, relying on our senses. So looking for smoke, smelling for smoke, listening to hear if we hear crackles, and a lot of times we had to put our hands in the dirt just to find the exact pinpoint hotspot.
So what did we learn? The thing that stood out most to us was the fact that firefighters go searching for hotspots with almost no tools, only using their senses and an unreliable map to locate hotspots. Once we identified our problem, we started brainstorming. Our final solution was a walking stick containing a thermal probe with integrated temperature and GPS systems. This probe updates live data into an intuitive, touchscreen arm unit and an easy-to-access web app. We call the system Ember Alert, powered by sensor technology with integrated communication kit, also known as STIC. So let's build.
We present Ember Alert.
The Ember Alert contains two mechanical components. The first component is the bolt action system to extend the thermistor and protrude it from the protective tip. This works by using an extension spring placed on the handle. The system will lock into place by sliding into a notch. This action is easily reversed to retract the thermistor. The handle design provides the option to allow for ambidextrous bolt placement and accessibility for left and right-handed users.
The tip, which also acts as a protective housing for the thermistor, seamlessly attached with threads. It screws onto a custom-made sleeve and acts as a stopper. This system makes the heavily used tip easily replaceable if needed. Finally, we have the STIC's Unit Intuitive Armband, specifically chosen for its snug and secure fit and easy adjustability.
At the top of the walking stick, there's a 3D printed handle that holds an ESP32 microcontroller chip. The chip is the main brains of the walking stick, connecting the OLED, LED alert system, and thermal probe to it. The OLED screen on the probe provides live temperature data being recorded, alerts the user to high temperatures, and refreshes every half a second. The alert system works on a threshold basis, alerting the user if the recorded temperature is too high, configurable by the user. Also being powered by an ESP32 is a touchscreen arm unit called STIC. Communicating with the information being recorded by the probe, STIC provides a live feed of thermal, GPS, and recording data through an intuitive user interface similar to current mobile phone systems. Currently, rep information can be provided via the STIC unit, hosting a widely accessible web app through Wi-Fi, providing live data to the guest connected to the system shown here.
This intuitive website design provides easy accessibility to live temperature via the Ember Alert probe, while simultaneously providing live GPS data from the STIC ARM unit. This custom web app sports an easy-to-use design with scrollable datasheet that can be exportable to a CSV file for various needs.
We have undergone several prototypes to troubleshoot and improve our final product to ensure optimal results. The tip had 4 prototypes within itself, consisting of altering the length and girth as well as exploring material types. An optimal material is still under development, as our ideal material would have heat-resistant and lightweight qualities. The head of the handle also underwent prototyping that has optimized the ESP port placement and incorporated an intuitive LED alert system. The grip of the handle had the most prototypes as it is the most complex piece in the probe. It also underwent the most testing due to the complexity of hand ergonomics. This saw the addition of a button and button placement, the ambidextrous bolt lever, as well as the ergonomic finger grooves. Finally, we come to the STIC unit, which was redesigned twice to perfect the fit of the touchscreen while also reinforcing the armband bracket to allow for a more secure and comfortable fit.
Wildfires leave behind a hidden danger, smoldering embers buried beneath the surface. These embers can reignite days, even weeks later, posing a serious threat to firefighters, communities, and fragile ecosystems. Ember Alert equips firefighters with the power of thermal detection and data collection. Our innovative probe quickly and accurately identifies underground hotspots, allowing for targeted extinguishing and faster cleanup. Having Ember Alert means knowing exactly where embers lie, faster recovery, and safer communities in a healthy environment for all. We're thrilled with what we've created, and we believe this can make a difference.